Our final example will be an example of using the fundamental theorem of calculus where we have to employ the chain rule. This is admittedly a kind of hard to recognize instance of the chain rule. So let's just look at the parts of what we're asked to do. We've got to calculate the derivative. We're going to take the derivative with respect to x of this function. This is one of those newly defined area functions where the independent variable is the upper limit of integration. But it's not just simply an x. It's not just simply the variable with which we're differentiating with respect to. It's a function of x. And so when we have in the past taken the derivative of a function whose input is another function of x, we have to use the chain rule. How do we do that? We take the derivative of the outside function, which is going to be that area accumulation function, so I'll abbreviate that area accumulation function. It's all this structure right here, integral sign, the differential, it's all of that structure with the upper limit of integration being the area accumulation function. And then the inside function is the 1 over x. Okay, so now we're going to apply the chain rule. We take the derivative of the outside function, which is the area accumulation function, with respect to x. How do you do that? You just evaluate the integrand at the upper limit of integration. We evaluated the integrand, which is cosine cubed, at the upper limit of integration. Then we multiply, and I'm going to do it in steps just so that we can see it. Then we multiply by the derivative of the inside function, which will give us cosine cubed of 1 over x, and then the derivative of 1 over x, you guys have probably done that a lot of times, is negative 1 over x squared. You use the power rule, and thinking of x to the negative 1 as, or thinking of 1 over x as x to the negative 1. There are other examples of this sort in the text, some where you might need to switch that upper limit of where the function of x or the function of the independent variable might be the lower limit of integration, and you might have to switch it using those properties of definite integrals that still work, that we learned back in an earlier section. And there's an opportunity to practice some more complicated questions like this in the exercises in our quiz.